Good evening, Pace. Myself, Rajeshwari Badagu. I'm working as assistant professor in the Department of Computer Science and Information Technology. Today, I'm going to discuss about the cryptography and network security. On cryptography and network security, we will go to see about the first of all aim of the session. Our aim is secure communication. Nowadays, security is the most important one to the data. Secure data is very important. That's why I'm going to choose the aim of secure communication. And in this, we are having two learning outcomes. First one is identify some of the factors driving the need of network security. And again, second one is compare and construct symmetric and asymmetric encryption systems and their vulnerability to attack and explain the characteristics of hybrid systems. And then going to main topic description is what is cryptography first of all. Cryptography is nothing but it is a term used in data communication that refers to protecting and private information shared between two parties. Network security refers to the securing and protecting the network and data ensures that particular data. Now we are going to see about network security model. First of all, this encryption cryptography is stands for in this network security model, data is transformed from sender to receiver. From sender to receiver, data is transformed by using the secret information, by using the secret information. Now, from sender to receiver, data is transformed. Message transformation through message transformation by using the secret information. Nothing but a key. Nothing but a key. For the message, actual message or this is the actual message or plain text, so on so on. For the plain text or actual message, we will add the key. Whenever add the key to plain text, that is called as a secret information. That secret information is transferred to the receiver through the information channel. Through the information channel. Through the information channel, next one, same. This secure information is there. This information is going to the receiver. This is the network security model. And again, first of all, going to see about what is cryptography. Cryptography is the science of secret or hidden written. It has two main components: encryption, authentication, and integrity. Encryption, authentication, and integrity. Encryption is nothing but converting the plain text into the ciphertext or converting the actual message or original message into the ciphertext. Next one, this is the encryption. First of all, we are having the plain text. This plain text or actual message is going to the ciphertext by using the encryption algorithm. On their encryption algorithm, we are having so many algorithms: AES algorithm, DES algorithm, triple DES algorithm, so on so on. So this plain text is converted into the ciphertext by using the encryption algorithm. And again, ciphertext is converted into the plain text through the using of decryption algorithms. Decryption algorithms. That's why in this we are having the key A, key B. Next one. this session, I'm going to see about the how plain text is going to the ciphertext. For example, I'll have the some plain text or original message. This is the original message A, B, C, D up to Z, A to Z. It will be going to the ciphertext by using the key. Here the key is method in which each letter in the alphabet is rotated by the 3 letters as shown. For example, here we are having D. For A, we are having D decryption, encryption code. For example, by 3 letters as shown, rotated by 3 letters as shown. For A, we are having A, B, C, D, D, fourth one. 3 times it will be rotated. Then D will be came. Next one for B, B, C, D, E. Third one is E. Coming to C, after C, D, E, F. Third one is F. Up to Z, we are having the 3 times rotation of the plain text. Whenever 3 times of rotation of the plain text, we are having the ciphertext like this D, E, F, G, H up to C. This is the conversion of plain text into the ciphertext by using the key. That key is rotated by the 3 letters as shown like this. That is the conversion of plain text into the ciphertext on our cryptography. Next one is, this is the from one of the example for encryption. Already we know about what is encryption. Encryption is nothing but converting the plain text into the ciphertext by using the key. For example, I'll take the example of, this is the plain text. Plain text is attack at dawn. This is the plain text. This plain text is going to the cipher into again ciphertext by using the cipher algorithm. That is the DWDFN DWGD YQ. Having third letter is D. After T for we are having third letter W. T we are having third double W. Last one N for adding the 3 count we are having the Q. That's why it will be converted into the plain text into ciphertext. And again by using the key. And again whenever completion of the ciphertext, then we will decrypt the data into plain text. This is the decryption process. In this decryption process, we are having ciphertext. Ciphertext will be going to the decrypt. Encrypt is this one. This one is decryption. In this decryption, we are having the input is ciphertext. In encryption, we are having the input is plain text, output is ciphertext, and again in decryption process, we are having the input is ciphertext and output is we are got the plain text. Now we will decrypt this code into the plain text. We will decrease the 3 letters from the D. D minus 3 letters of alphabets, we are got the A letter. For W, we got the T letter. For W, we got the T letter. And again up to Q, we are got the N letter. That's why we are going to the decrypt that plain text. That is the by using the key. That is the process of encryption and decryption by using the key. So this is another example for decryption and encryption. same as like that, same as like that. Another example is, this plain text is going to the cryptographic method by using the keys. Here we are having two ciphertexts. So two ciphertexts for the plain text. This is the plain text A to Z alphabets. For A to Z, for A in the C1 key, we are adding the 6 letters. For example, A, B, C, D, E, F. Sixth one is F. From the B, we are having the sixth letter is G. For C, sixth letter is after sixth letter is the H. After H, we are having sixth letter is M. Up to Z, after Z, we are having the sixth letter is E. For example, Z, A, B, C, D, E. That is the K1, key 1. That is the ciphertext 1. Coming to C2, ciphertext 2. After A letter, we will add the 20th letter. A after the 20th letter is T. K after 20th letter D. P after 20th letter I. Up to Y after 20th letter is R. That is the, by using the two keys, ciphertext 1 and ciphertext 2. This is the doubled encryption process. Double algorithms we will add. For example, this is the original message. This is the, by using the cipher algorithm, we will got the encrypted code we are having. Next one. Cipher. These are all about the cipher. The amount of security needed should determine the amount of labor appropriate for the encryption and decryption. And again, the set of keys and the enciphering algorithm should be free from complexity. And again, the implementation of the process should be as simple as possible. And again, errors in ciphering should not propagate and cause corruption of further information in the message. And the size of the enciphered text should be no longer than the text of the original message. These are the some conditions to follow the ciphers. And again, encryption system. This is the encryption system. In this, we are having mathematical operations, we are having arithmetic, like arithmetic operations we are having, so on, so on. And again, after this one, finally we are coming to the DES algorithm, data encryption standard. This is one of the most popular algorithm in the computer network and computer security as well as cryptography. By using the DES algorithm, we will go to the secured communication of that particular data. So, first of all, goal of the DES is to completely scramble the data and key, so that every bit of ciphertext depends on every key bit of data and every bit of key. DES is a block cipher algorithm encoded plain text into 64-bit chunks. One parity bit for each of the 8 bits, thus it reduces of 56 bits. It is the most used algorithm in our daily life. And again, DES algorithm has the versions. Single key, by using the single key, it is called as a DES, just simple DES algorithm. By using the, it is called as a double DES algorithm. By using the 3 keys, it will called as a triple DES algorithm. DES algorithm has 64 bits of ciphertext and again 64-bit key on that process it is having. And again, DES algorithm, data standard encryption algorithm is has a totally six steps of process. Six steps of process. And again, each step has a 16 round. Each step has a 16 round. And again, every round has again 5 steps. Again, 5 steps. And again, we are going to, first of all, we will see about data encryption algorithm in cryptography. Already we know in data encryption algorithm in cryptography, we are going to plain text into the ciphertext, and again we are going to the again plain text. In this we are having three types of terminologies. First of all, plain text. Second one is ciphertext. Third one is secret key. Plain text is nothing but original message or original data. Ciphertext is encrypted plain text with the combination of key. And again we will say about ciphertext is nothing but combination of plain text and again key. Combination of plain text and key we will call as a ciphertext. This is the process of DES algorithm in cryptography. First of all, plain text is going to the ciphertext by using the encryption. On that encryption, we will add the key, secret key into the plain text. And again, this will be going to ciphertext. Ciphertext is going to the plain text by using again the secret key. This secret key and this secret key are same. This is called as a symmetric key. Symmetric key is nothing but we will use the same key. Asymmetric key is called as we are using the two different keys. On that we are having public key and as well as private key. That is called as a asymmetric key cryptography. This is the simple process of decryption DS algorithm on cryptography. And again, this is the double DES in cryptography. Double DES in cryptography. Double DES is nothing but we are having two keys we are having in double DES algorithm. Nothing but original text or plain text is going to the ciphertext or temporary ciphertext, that is the T1, and also it is called as a C1, ciphertext 1. This ciphertext 1 is going to the again encryption process by using the key 2. This will be going to the C2, nothing but ciphertext 2. This is the double DES, and again we are going to the triple DES also. In triple DES, same as we are having original plain text, and again original plain text is going to the C1, ciphertext 1 by using the key 1, and again we will give the encryption process to for that particular C1, that means ciphertext 1, that will be going to the C2, ciphertext 2. Again for the ciphertext 2 we will give the key 3. By using we will add the key 3 onto with the decryption, we will going to the final ciphertext C3, C1, C2, C3, again key 1, key 2, key 3 we are having in double DES. This is the triple DES in encryption. And again finally we are going to the DES algorithm steps. In this DES algorithm steps, already I'll tell about this one. 3 steps we are having. This is the first step. This is the first step. 64-bit plain text is going to through the this first step. In this first step we are having initial permutation. IP we are having in first step onto that particular DES algorithm. Plain text is going to the initial permutation And again, after initial permutation, it will be divided by the left plain text and right plain text. Left plain text and right plain text. On that left plain text, we will perform the 16 rounds with key. 16 rounds with key on right. This is called as a step 2. Step 2. This is the step 1. And finally, third step is this one. Final step or step 3. Third step. Final permutation. This is the overall 3 steps on our DAS algorithm. And again, this is the broad level steps in DAS algorithm. This is the some elaboration of that particular data encryption standards. In this, we will give the 16-bit input and 56-bit key. And again, we are having left and right 2 parts, and again left and right 2 parts, and again left and right 2 parts. Each step, each round, we are having left and right steps also. And again, these are the 5 steps onto that every round. First of all, DS has a overall 3 steps. On that every step, first step is have the initial permutation IP. That is the first step. Second step is, on that second step we are having 16 rounds. And third step is has a final permutation FP. On that second step we are having 16 rounds. On that every step, every round of that particular 16, we are having 5 steps again. 5 steps again. First one is key transformation, exponential permutation, S box permutation, P box permutation, finally XOR and swap. 5 steps we are having in each round. For each round, we are going through these 5 steps. That is the overall steps for each round. That is the DS algorithm. Coming to AES algorithm, this is one of the another cryptographic algorithm. This is the advanced algorithm from the DES. AES algorithm is a specific location for the encryption for electronic data established the US National Institute of Standards and Technology. NIST. Now, after completion of DES algorithm, we will go into the AES algorithm. AES is nothing but Advanced Encryption Standards algorithm. This is one of the advanced version for the DES algorithm. Coming to AES, AES algorithm is a specific location for the encryption of electronic data established by the US National Institute of Standards and Technology in 2001. AES is widely used today as it is a much stronger than DES and triple DES despite being harder to implement. And again, this is one of the block cipher algorithm, and again DS also block cipher algorithm, and again AES also block cipher algorithm. Nothing but plain text is divided by the blocks wisely, and then going to the encryption and decryption process. That's why it is called as a block cipher. And then finally the key size can be, here we are having some variations, 128 bits, 192 bits, 256 bits, so on so on. But on DS algorithm we are having only 64-bit size only. Coming to AES, we are having 128, 192, 256 bits also. And again encrypts data in blocks of 128 bit each other. This is the some description about the AES algorithm. And again AES algorithm means it takes 128 bits as input and outputs 128 bits of encrypted ciphertext as output. AES relies on substitute permutation network principle, which means it is performed using a series of linked operations which involves replacing and shuffling of the input data. And again, it is working of the cipher like this. AES performs operations on bytes of data rather than in bits. Since the block size is 128 bits, then cipher process as 128 bits or 16 bytes also it is called as, and again of the input data at a time. Coming to AES algorithm, we are having some rounds of depends on this key's length. On DAs we are having only 16 rounds only, and again coming to AES we are having variations of that particular rounds compare with the bit size, that is depending upon the bit size. Each rounds of the algorithm is depending upon the bit size only. For example, 128 bit of key we are having, for that we are having 10 rounds, and again 122 bit size of key we are having 12 rounds, and again 256 bit key we are having 14 rounds. That is round numbering is depending upon to the bit size of that particular bit size. And of the creating of round keys, a key scheduled algorithm is used to calculate all the round keys from the key. So the initial key is used to create many different round keys which will be used in the corresponding round of the encryption. And again, this is the some overall block diagram of AES algorithm. AES algorithm. Now we are going to see about the differences between AES and DAS. DAS is nothing but describes as a data encryption standard, and AES is nothing but uh, advanced encryption standard. On that DAS we are having 3 steps. On second step each round has a 5 steps, and again on that we are having no variations about the key bit size. Coming to AES, we are having some advantages with the compare of the DAS algorithm. In AES algorithm, we are having no 3 steps, no rounds, no key bit size. Coming to AES algorithm, we are having plain text. Each plain text on that this is the overall block diagram of AES algorithm. For this AES algorithm, we will give the input is plain text. That plain text is going to add round key step, and again we are having 4 steps for each round. This is the round 1 up to round n, and again round 10. Finally, we are having the round 10. For round 10, we are having how many bits? 128 bit key. For round 10 rounds, we are having the bit size is 128. That's why this plain text has a 128 bit size. 128 bit size. 128 bit size is having the 10 rounds. Round 1, round up to round 9, round 10. For each round, we are having 4 steps. Substitute bytes, shift rows, mixed column, add rounds. On that, we are having some calculations of that particular plain text into the ciphertext. Whenever completed the round 10, we will got the ciphertext. Again, this ciphertext is going to the decryption algorithm to the substitution of that particular encryption process. On ciphertext, we'll go through the round key, round key. So on this round 1, we are having again 4 steps: round 1, round 2, round 3, up to ninth round, up to 10th round. 10th round we are having. Finally, we got the plain text. That is the AES algorithm performed that particular encryption and decryption process. For this side, we are having encryption process. For this side, we are having the decryption process. For this side, we are having decryption process. This is the decryption process, encryption process, decryption, encryption and decryption. Plain text, for encryption, we are having the input is plain text, output is ciphertext. For the decryption, encryption, input is ciphertext and output is plain text. In between this one, we are having 4 rounds. 4 rounds. First one, substitute byte, shift rows, mix column, add round key. That is 4 steps on round 1. And again up to round 10, we are having same 4 rounds. N minus 1, this is n minus 1 round, this is the nth round. Same as and again same as 192 bits, we are having 12 rounds. And again same as 250 bits for 250 bit key, we are having the 14 rounds. Like that seen on that particular. So this is the AES algorithm. Thank you for listening this lesson. Thank you.